Good afternoon. My name is Cynthia DeWitt. I'm a professor here at Stockholm University. I'm at the Department of Environmental Science and Analytical Chemistry, and I'm standing here as the chair of the board of the Bolin Center for Climate Research. And once a year, we nominate a person to come and hold the Bert Bolin Climate Lecture, and we put this forward to the Dean of the Faculty of Science, and he makes the final decision. And I'll start a little bit on Bert Bolin. Bert Bolin was a professor of meteorology at Stockholm University, and he worked with the carbon cycle. And he was one of the first people, I think, who started to understand the implications of carbon dioxide releases and changing climate. And he helped found the Intergovernmental Panel on Climate Change and became its first chair. And the IPCC puts out these assessments every 4 or 5 years that make big press and usually talk about whether or not climate change is happening, and if it's happening, how fast and how much is caused by human activities, burning coal and oil and fossil fuels and the like. And in the past, these likelihoods have gone steadily upwards to where we now are it's pretty clear that we as human beings are changing the climate of the Earth. And Bert led IPCC for a long time and then had to step down. And it was shortly after he stepped down that IPCC won the Nobel Prize for peace. And I think that was a great honor for him to have been part of that. So this lecture, the Bert Bolin Climate Lecture, then is a tribute to Bert Bolin and all that he did. And we usually nominate someone who will talk to us about climate and climate change in some aspect. So I'm going to introduce Len Berry here, who's going to introduce our speaker. I would also like to say, any of you have phones, which I assume is everyone in this room, please be sure they are on silent so that they don't start to ring in the middle of the talk. And now I'll introduce Len Berry. Professor Len Berry, please.
Good afternoon, everybody. It's my pleasure to introduce our 9th annual Bert Bolin Climate Lecture, Professor Sir Brian Hoskins. We've covered pretty much, Cynthia's covered very well, a little bit of the background on Bert Bolin, and I will go directly to introducing our speaker today. Let me start with some history of his studies and research. He has degrees in mathematics, foothold in mathematics from the University of Cambridge, postdoctoral years in the US before moving to Reading University. He became a professor in his 30s and was head of a department for 6 years. And for 10 years, ending September 2010, Brian has held a British Royal Society research professorship. His research is in weather and climate, and particularly understanding of atmospheric circulation. I might say currently he is the first director of the Grantham Institute for Climate Change at Imperial College, London. And since beginning in 2008, he shares his time between Imperial and Reading, where he was professor of meteorology and is. Finally, he has international recognition through many roles. He was vice chair of the Joint Scientific Committee for the World Climate Research Program, which was founded in 1985, just 3 years before the Intergovernmental Panel on Climate Change. He was president of the International Association of Meteorology and Atmospheric Sciences, which is a very prestigious international umbrella science organization. He has had involvement in the 2000 Intergovernmental Panel for Climate Change Science Assessment, which won the Nobel Prize, Peace Prize. He's a major contributor to the 2000 report by the British Royal Commission on Environmental Pollution that first proposed a 60% target for the United Kingdom in reduction of carbon dioxide emissions. As far as international awards, very many. I'll just name three. The top prizes of the UK and US Meteorological Services, the honorary doctorates from the University of Bristol in East Anglia, and in 2007 he was knighted for his services to the environment. So today he will speak to us on this topic, and without further ado I would ask you to join me in welcoming Professor Sir Brian Hoskins.
Thank you. Well, thank you, and it's a great pleasure to be here today. I knew Bert Bolin quite well, and it's certainly an honor to be here. So I'm going to be speaking on climate change, and it's really the challenge to us all as scientists, technologists, politicians, business people, or just members of society. And I'm going to take a quick turn through the whole problem, starting from the science, because I missed that out, then I haven't really given you the background. And I'll try not to lose you on the way, but if you find something a bit hard going, just switch back in again in a couple of minutes, and hopefully you'll be back in and where you can understand what I'm saying. So I'm going to go right back to the beginning and say, well, why are we concerned about this? Well, first, not why are we concerned, but why is this a good thing in some ways? So over here you have the sun, and here's the earth, and there's the sun's radiation shining down on the earth and making the earth warm up and be a pleasant place to be. However, if the earth warms up, then it gives off heat radiation, and then you get a balance between the incoming radiation, the solar radiation, and the heat being given off. And that makes the earth a certain temperature, and without an atmosphere, that depends on how you do it, but something like -18 would be the average temperature of the earth, and we wouldn't be here, and this wouldn't be a very pleasant planet to live on. So that's the situation with no atmosphere. And if we have some greenhouse gases in the atmosphere, then that atmosphere lets the solar radiation through, so it doesn't stop any of that. However, it absorbs the heat given off, and it absorbs it, and it then re-radiates it. So it re-radiates it in both directions, out towards space, but in towards the planet. So that then tends to warm up the planet more. And the balance is achieved only when this radiation given off at the outer parts of the atmosphere is enough to balance the incoming solar radiation. So that warms up the whole thing. You let the solar radiation through, but you stop the heat escaping and then re-radiate it. And the number one, so this would be makes us about 33 degrees warmer on average. So the temperature of the Earth is maybe +15 rather than -18. So that's pretty good news. And that's the greenhouse effect. It's good news. And the number one greenhouse gas is water vapor. Now, am I in the way of this for some of you? Right, I'll stand over here. And I'll keep waving this, and if anyone goes to sleep, I'll wave it even more, right? So we're warmer, that's good. And number one greenhouse gas is water vapor. Now, you don't hear anyone saying we must stop producing water vapor because it's warming up the Earth. And that's because water vapor is an inherent part of the climate system. If by any chance we could add a lot more to the atmosphere, within a few days it would have rained out and it would have achieved its own balance. So water vapor is part of the balance of the climate system, and we don't perturb that directly. So that's the number one, in a big way, water vapor. The next one on the line is carbon dioxide, and that one you do hear something about if we add some more of that, then that could make a difference. There are others, methane is the next one, but others down the line. Now, this is not news story here. Fourier, who you might have heard of in something to do with series in mathematics, Fourier series, then he was a mathematician. He said, well, there must be something like this going on. Tyndall, actually, in 1861, he was at the institution Imperial College where when he did these experiments, and he actually showed that gases like carbon dioxide do indeed absorb heat. And then Arrhenius, who was very much celebrated here, Svante Arrhenius, he actually did some calculations about how changes in atmospheric carbon dioxide might change the temperature of the Earth. He was particularly concerned with ice ages, but he did also mention the future. And he gave some calculations which still aren't far off what we would suggest today. But anyway, the greenhouse effect is great. It makes our planet habitable. But like a lot of things, too much of it may be not too good for us. And that's where we come in terms of the extra carbon dioxide. So this is the measurement of carbon dioxide in the atmosphere. Back in 1957, someone was able to persuade the funding authorities for him to go to Hawaii and stay there and measure carbon dioxide. And what an amazing thing to do. So we find difficulty persuading our funding authorities today to send us to nice places and just sit there. But anyway, he knew that there was a reason for this. And so these are actual measurements in Mauna Loa and Hawaii since 1957. And you can see the atmospheric carbon dioxide going up. This red thing is the annual cycle associated with there being more vegetation in the northern hemisphere that soaks up carbon dioxide in the spring and then gives off more in the autumn. But ignoring that then, if we take the black curve, you see this rise. And it's a rise from something about 310 back here to something over 400 today. That sounds quite a large rise. Well, maybe the Earth has always fluctuated these. If we go back over the last 2 million years, then the fluctuation in carbon dioxide was down between 220 and 280 as we went through. So these levels here are way above what has been there in the last 2 million years. Now, so does that matter? Well, first, this is due to us, and mainly due to the burning of fossil fuels. I won't go through the details of how we are very confident about that, but it is extremely, there are many different sorts of evidence that this is due to our activities. In particular, then, this is calculated to be about half of what we've put into the atmosphere during that time. And the other half has been almost equally absorbed by the atmosphere, by the ocean and by the land surface, by vegetation and the soils. So it's about half of what we've put in there. So the amount is about right, and that's one of the lines of evidence. Now, carbon dioxide is a particular concern because if you drive down the road now, that will influence the amount of carbon dioxide in the atmosphere for the next 1,000 years. So you come back in 1,000 years, then for every 100 tons put in, somewhere between 15 and 40 tons extra would be in the atmosphere in 1,000 years' time. So we can't decide one day, right, we'll change what we're doing now and everything will just return. We have set the course for the next 1,000 years. So adding carbon dioxide in the atmosphere, it's a greenhouse gas and it warms the climate. And it warms it now, and because it lasts so long, it warms it into the future. Other greenhouse gases are there. We're adding to those. And at the moment, those are equivalent to about 20% more carbon dioxide. But we're particularly concerned about the carbon dioxide because of its large amount and also the time it will stay there. So is the climate warming? Well, there's various series you can look at. But we can, from the measurements around in previous time, get a good idea of what the globally average temperature was. Now, that sounds difficult because there weren't too many people with thermometers back in 1880, but there were some. And people have analyzed this data in various ways, and they've always come up with almost the same curves as these for the change in temperature from 1880 through to the current day. And like all the series to do with our planet and measurements there, it goes up and down, and there's some idea of the error bar here, but it goes up and down, up and down, and up and down, but the rise over the longer term is evident. Now, there was a lot of interest or comment on the fact that temperature hadn't gone up much since 1997, so through this period here. However, it was consistent with what had happened in the past, the fluctuations. In fact, in a meeting in Downing Street, which is where our Prime Minister is, in late 1980s, I said the temperature wouldn't necessarily go up for a decade or more. In fact, it could go down, but it wouldn't mean the whole thing had gone away. And after this period here, in fact, the last 2 years have been records, this last year being a particular record. So that when you look through the series, this period is no different from these previous periods that the globe has gone on warming. And that warming is consistent with the sort of calculations that Arrhenius did and more sophisticated calculations of today. Just showing this another way, Ed Hawkins at Reading has shown this way of showing it. Shows slightly off the bottom here, but that's January to December here. And this is 1850, this color. So these are to do with the 19th century, these here. But so this shows the temperature through the year back in all these times in the past, and then gradually getting through to the 1950s, and then the 1990s through to today. And that's 2015, this one here, and that's 2016 so far. The warmest our planet has been for a very long time. So you can see the changing colors here, and there's fluctuations, but the inexorable rise of the temperature with these incredibly warm months, the record months of March, and February and March. So is this just a global average? Well, no, it's not. And this is actually taking the period, the late 20th century to early 21st century. So looking over the change over 100 years. And again, a number of centers have done this, but this is actually from NASA, this one. And it shows the change in temperatures. These red colors are over 1 degree warming in that 100-year period. And the more yellowy orangey ones are something between 0 and 1. Almost everywhere the temperature's gone up, and the global average during this period is about slightly under 1 degree. And you can see over the oceans, then, if anything, it's below that global average. But almost everywhere over the land surface, it's more than the global average. So we're looking at 1 degree or more over the land surface. And in many places, particularly the northern continents, it's more like 1.5 to 2. So almost everywhere has been getting warmer. There, over the Atlantic Ocean here, there's a particular place that hasn't, and that's for reasons to do with the ocean circulation in particular. So almost everywhere is warming, and looking at just a few other things to do with a warming climate system. As the climate system warms, then some of the ice melts, and also the water of the ocean expands. Now, we don't think of water as expanding much when you heat it, but it does it a little, and that leads to sea level rise. So the melting ice and the expansion of the ocean lead to sea level rise. And this is the, from 1992, this is the change, this is the sea level around the world, averaged around the world. And maybe you can't see the numbers here, but this is a change of something of the order of, over that period, maybe 80, 90 millimeters during that period. So we're looking at something which, if we look at the trend, is 3 millimeters per year. Now, that doesn't sound much, 3 millimeters per year, but if you say a decade, well, then that's with thinking of 3 centimeters. And if you think of 100 years, then this is something like 30 centimeters. So that's the way sea level has been rising during that period. And that is a signature of a warming planet. And I've only taken one other series here to show, and that's the Arctic sea ice area. Like other series, there are lots of fluctuations in this, but first to explain, the Arctic sea ice will grow throughout the winter period and be a maximum around March, April perhaps, and then it will get less all through the summer period and be a minimum in September. And this shows the minimum sea ice area in September ever since we've had satellites observing it. And you can see there's a lot of fluctuation but there's also a downward trend here. And these numbers are large. That's 8 and that's 4 million square kilometers. So it's almost talking about a halving if you go from there to there of the area. Well, we haven't had that. And there's been a lot of discussion of this. If you want to believe the planet's going to a disaster and you reach one of these periods, you say the Arctic sea ice will disappear in a few years. Or if you want to have a newspaper that says there's no problem, then when it recovers here, you say it's all gone away. But I think if we take a slightly longer look at this, we'd say there's just a downward trend in this, and that's this last September there. And that trend corresponds to the sea ice disappearing somewhere in the summer of the mid-century. And of course, it will grow again in the winter, but it will be less sea ice there. All indicators of a warming planet. And we've had many events talking about extremes in summer heat. And you would expect that if the planet is warming, and I've picked off a few here. This was a heat wave in Russia in 2010. And if you have a sort of normal curve, this was 5 standard deviations above normal for a month or for a whole season. So it was huge, and the forest fires around Moscow made the Soviet Union, or Russia, very concerned about climate change. And Australia, almost every record you can think of was broken in the period up to September 2013. I picked off another one, Phoenix. The minimum temperature was 34 one day. That's a record. Summer 2015, many records there. That's actually the road in Delhi, which wasn't too good for riding this motorbike on, I don't think, at that point. And just in March here, there was a record temperature of the sea around the Great Barrier Reef off Australia, and the bleaching of the Great Barrier Reef is a real problem there. So there are many hot events, as one would expect with a warming climate. But I want to give a balanced talk and actually say there's been some interesting, although not interesting if you live there, extremes of the other sign. And particularly in Europe here, we've experienced some. This is the winter of 2009-10, where that blue color means it's actually very cold for the winter. And in fact, over northern Russia here, it was about 8 degrees below normal. And this is the December 2010, which was actually a record in the UK, a record cold December, and that's in a record lasting 200 years, so an extreme cold. Now, if you look at these, there's a very definite pattern here with cold in this region and very warm over this region here and to the south here. And in fact, the hemispheric temperature was above normal. But there's a very persistent weather pattern. And one day in London, when the temperature was not going above 0, I looked at the weather details around the world, and in Greenland here, the temperature was +10. So there was a very persistent weather pattern there. And this is a very interesting aspect. This persistence, because these were records, means that was almost a record persistence of that pattern. So that's one of the interesting indicators, perhaps, that we should be looking out for of a changing climate, because we don't understand that at present, but it could be an aspect of a changing climate. In fact, people have looked at the weather patterns that existed here, and if you go back in the past, those weather patterns would have made us about 1 or 2 degrees colder than we actually were. So it's the persistence that's important. It was actually comparatively warm considering the pattern we had. And there's another one for the USA that made a lot of noise as well. So there's been rainfall records as well. Well, why would we expect those? Warmer air, the warmer the air is, the more water it can hold before it condenses. And in general, a warmer atmosphere is found to hold more water vapor. It can evaporate until it reaches some equilibrium level. So that means the same storm that squeezes the water out of the air can squeeze more water out. So it would suggest that extreme rainfall events would become more extreme, or the number of heavy rainfall events would increase, to put it another way. And that is found around the world, that has actually happened. But equally, then, if we look at some of the more detailed ones, There's been some interesting things in the UK in this period, and I've put mainly those, I think. So we had a record rainfall in this period here, and that was followed by a record dry September, and those records are 100 years. So we're not looking at something that's just happening. And I was giving a talk in India, and these major flooding events that happened there were extremely interesting, but to a scientist, but extremely concerning to those who live there. In the area Syria to Palestine, the drought in this period, which has also helped create some of the unrest in the area, is estimated to be 50% drier than any in the last 500 years. So things going on there. And the tropical cyclones. Again, why tropical cyclones? Well, a simple idea is tropical cyclones get their energy from the ocean. And the warmer the ocean, underlying ocean is, the more energy that is available to them. So theoretically, you can expect there is a possibility of stronger tropical cyclones. Now, there are many other determinants of actual tropical cyclone occurrence, but this gives a basic idea that they may become stronger, or some of them may become stronger. And we've actually had a record winds in these for the landfall of this in the Philippines in 2013. This one was a record in the Western Hemisphere in 2015. And we had this cyclone wandering up here, and they usually turn this way, and this one turned left into New York. Now, there's no way I'm saying that that is because of climate change. However, the impact may be slightly greater. Certainly, the sea level is now about 20 centimeters higher than it was estimated to be. And if you get a surge associated with a tropical cyclone and there's 20 centimeters more water there, then the overtopping is that much greater. And the warmth, the extra degree or so in the sea surface temperature around here probably added a little bit to the intensity, but certainly the course we can't say. But there's, again, interesting events going on. Now, this is looking at the records we have, some of which are very consistent with that warming, others, like that extreme cold, not what we'd expect in the first place, but if the variability increases, then it could be. So now we want to look towards the future, and these are pictures taken from the Intergovernmental Panel on Climate Change report in 2013, which Bolin was very much the starter of that whole thing. Now, if we're going to look to the future, we have to use models of the climate system. And those models are developed from weather forecast models in the first place, and then various other components added with the deep ocean, the land surface, the biosphere, maybe the atmospheric chemistry. So those models then are evaluated on the past, see how they perform, and do they do things well for the past. And then if you're going to look to the future, you have to say, well, what greenhouse gases are we going to add to the atmosphere during that period? So the future depends on which scenario you take for greenhouse gases. And I'll be showing just two from all these. One of which is that we really take this very seriously, and we stop the emission of greenhouse gases as much as possible. That's this one. Or the other is that the emission of gases continues much as the direction we're going now. So this was this time here, around 2006, 2005, and then the future here. Now, if we look at these, we should add on to these numbers about 0.6 of a degree, because this is already warmer, was already warmer than the pre-industrial period. So this low one here would correspond to a rise in temperature of about slightly under 2 degrees with some uncertainty about it. This is the range of models that's showing that uncertainty. So that's slightly under 2 degrees. This one here is more like 4.5 degrees with, again, it could be 3.5 or it could be 5.5. So the upper one is about 4.5 degrees warmer. That's quite a bit, as we'll see, and this one is about 2 degrees warmer. So those are the globally averaged pictures. But if we take the upper one of those and look at what the models suggest would be the distribution of temperature, and this is the annual average, then these you can see over the ocean, then the numbers are somewhere below that 4 degrees. They're more like 3 or 2.5 to 3. But over the land surface, they're almost everywhere more. So they're more like the 5 degrees. And then over the northern continents, they're even more than that. And in wintertime, we'd be looking at something like 10 to 12 degrees warmer in these northern continents. Now, I'll be talking about impact in a while, but in fact, it's the tropical countries that might well suffer most from this, because the variability from one year to another is less in the tropical countries. So that plus 5 degrees in the tropics would be much more different than the variability that's used to than maybe in the higher latitudes. But everywhere these are large. And it isn't just warmer. The weather systems we have feed off temperature contrast. And you can see the temperature contrast would change. And that means the weather would be different as well. So we're looking at a warming system, warming more on the continents, and the weather being different. One other picture, rather than showing rainfall changes, I'm showing what would be the change in the moisture in the soil, because that's what the plants would feel. So it's warmer and the rainfall would change. And these are significant changes here of drying. Some places slightly wetter, but little confidence. The confident signal here is of the drying in the Mediterranean region, over Australia, southern Africa, the Amazon region, and southwest US. So big drying of regions where many people live. So some other quantities then. Sea level, I've already talked about the warming ocean expanding and the melting of ice. And already we can see a contribution from Greenland, from the reduction in the Greenland ice sheet, and some contribution from Antarctica as well. And those may be expected to continue and increase, but in fact these do not include any great increase from those sources. So even without that, then we're not seeing too much separation between the two, but if we take the upper one here, it's something like 0.8 of a meter. And if we add on the 0.2 meter that already had occurred, then that's about a meter or slightly under change in sea level expected for the end of the century. And if anything, as I say, that's liable to be an underestimate, because there could be a greater contribution from the Greenland and Antarctic ice sheets. I'll just show one more then, which often is not mentioned, but this is as the atmosphere gets more carbon dioxide and some dissolves in the ocean becomes more acidic. And this shows projections into the future of how the ocean may become more acidic, in particular with this high emission scenario. And there is not great knowledge of what that would do to the biology of the ocean, but it's very clear that for animals with shells in the ocean, that could be a real problem. So the climate change problem, we have these projections of the future, but if everything else was simple, then maybe we could cope with some of that. However, we do have other problems at the same time. We have a growing world population, moving largely to the cities. We have changing diet, moving towards a more Western diet with more meat, which leads to more emission of greenhouse gases from those feeding those diets, and increasing demand for food, water, and energy, and many other global environmental changes at the same time. Now, recognizing the problem of sustainable development around the world, so all the countries of the world that desperately need to develop, then the UN in September of 2015, there was agreement on sustainable development goals down here. Now, climate change is just one of these, and I won't go through them all. There's poverty, there's health, whatever. Climate change is one of these, but it plays a major role in many of the rest of these. But this is the context. We aren't looking at climate change in a world where everything else is in equilibrium. We're looking at climate change in a world that is under stress in many ways. The impact of climate change itself, as many people have tried to work out what this might be, but this is one from a project in the UK talking about the number of people exposed to increased water scarcity, river flooding, the species, 50% of plant species losing more than half their habitat, cropland less suitable for agriculture, and exposure to heat waves. So you can put on numbers on these. I wouldn't like to say those numbers are accurate, but there clearly are many impacts one's looking at. So we've reached this problem, and can we do anything about it? But just before we do then, I've given you some view of the change in climate that the models suggest on average. But actually, I think we are looking at what we get if we're lucky. Because those are very smooth changes, and they're the average of lots of models. Now, what we know about systems, complex dynamical systems like our planet, is that they tend to go through thresholds where their behavior changes. Now, the models don't get any of that. And those models, equally, do not, when we try them on the past, if we try them on the monsoons, for instance, when the Sahara Desert was green, and you try the models for those, they cannot move the monsoon inland enough to make the Sahara green. So there's evidence they don't depart from as much from today as has been observed in the past. And we're lucky if that's going to be the case in future, that they don't underestimate the changes. So there is an increasing chance of thresholds, crossing thresholds, and we don't know anything about that. Those thresholds could be in climate, or they could be in the natural systems. If you add 5 degrees onto the pre-monsoon temperature in India, where the temperature is already 45, and you take it to 50 or beyond, people are not able to do any activities in those sorts of temperatures. So society would cease to function during the daytime. So society would cross a threshold even if the climate system had not. So we're performing a very dangerous experiment with our planet. We only have one planet. If we had a few, we could try this on one and see what happens. But we only have one. And we may be at the bottom of the range on everything, you know. So there's a 1% chance, perhaps, that we'll get away with it and everything will be slightly less than I've said. If you want to bet on that, I don't, and you're younger than I am. So we want to do something about it. So I'm going to say what we do. Well, first, we can adapt, and that's sort of saying, well, climate will change. Can we adapt? And there's no doubt that we have to adapt, because things will change anyway. And in many parts of the world, the first part of adapting is adapting to the extremes that we already see. So in many developing countries in particular, then the extremes of weather are always causing great impact, and dealing with those is number one. But then the second part is planning to cope with possible future extremes. And this can be done in many ways, but I'm going to show one example from the UK, the Thames Barrier. You may be aware that to protect London from flooding, there was this Thames Barrier that was erected. I can't remember how many years ago now, but it was thought it would hardly be used, but it's used a lot now. But there's thought already about how much do we have to increase that barrier in the future. And you can't see all this deliberately, but this is some planning that's been gone through, where at various stages decisions can be made that will not stop coping with the next level. So if you follow it through this way, it would actually cope with a 2-meter sea level rise by 2100, because we think that's the absolute limit of what it could be. But if it's only 1 meter, you'd follow this through in another direction. But the thing is, at every point, you don't close off the possibility of dealing with that. So it's adapting, but doing it in an intelligent way of actually being able to be flexible about what the future might be. So that's adaptation. Do something else to compensate. Okay, so we're mucking up with the climate system one way. So let's see if we can do something else. Well, one would be to remove the carbon dioxide directly from the atmosphere. It's much easier to stop it getting there in the first place. However, if we put it there, can we remove the carbon dioxide? And there's a number of ways that this can be done. I won't go through these in detail, but these are things to do with putting in trees, managing the carbon in the soil, perhaps putting on something on the soil to help it absorb more carbon, or using the biomass and keeping those trees and not burning them. And here, so those are things we should do anyway. These are slightly more problematic. So this one says, well, over the ocean, could we persuade the biology in the ocean to absorb more carbon dioxide and then sink to the bottom of the ocean, so taking it out? And the ocean is deficient in iron, for instance, in some regions, and people have tried putting extra iron on the ocean and then seeing the biology flourish, although it changes the balance in the ocean ecosystem, and then after that initial flourishing, it goes away. So if you could keep putting iron over a lot of the ocean, it might make some impact, but it's generally such a huge thing to contemplate, and the change to the ocean would be dramatic. The last one here then, direct air capture. So people are trying to see if you, maybe in the desert regions, you can get enough energy from solar power to actually capture, to put the energy into capturing carbon dioxide from air and then liquefying it and putting it underground. It takes a huge amount of energy to do this. And another thing mentioned is to grow biomass, to use crops and then use them and capture the carbon as it comes out of the chimney, and again either use it or put it underground. So that's seen as a sort of negative carbon technology. So there are things we should definitely do, and these are being thought about down here. Now there's the next one in this list here says, really comes from that initial view I gave you, where we've got the sun's energy coming down and the greenhouse gases are stopping the heat escaping, and that we've got more stopping the heat escaping, so why don't we stop some of the sun's energy reaching us? Which may sound a bit dramatic. I know in Sweden you love the sun when it comes out, but anyway, we have to think of desperate things here. So this goes under the name of solar radiation management, climate interference, or geoengineering, according to how respectable you want to make it. And so this is some suggestions for this. Well, you can put umbrellas in space using rockets, or else you can try and make the clouds a bit whiter, or you can make the land surface much whiter. All those are a bit far-fetched, but the one people are considering is actually putting more aerosols, more particles into the high atmosphere, mimicking what volcanoes do. And those particles would spread over if you put them in the equatorial region, they would spread over the globe and then descend to the Earth again. They'd create very nice sunsets, and they'd stop a little of the solar radiation. They may perturb the chemistry of the stratosphere, which is the sort of thing I'm mentioning here. And there may well be other impacts. Once one started this, if you decided to do this as a way of compensating all the carbon dioxide you're putting in, you would have to keep going for the next 1,000 years, because as soon as you stop, then it would re-emerge within a short period, as soon as those particles had spread over the stratosphere. So this is, if contemplated, this would be something that we'd hand on to the next 10 generations or more as having to do. And it's really unknown implications of doing this. So we come to number 3 here, which says, well, can we stop emitting as much greenhouse gases as we're doing? We have to adapt. Can we do this? This goes under the name of mitigation. Can we lower those emissions of greenhouse gases? And this is one estimate from a UK group. If the emissions of carbon dioxide continued to rise, or if they stabilized, or if they went down, how would we change some of the impacts? And this is heat waves, cropland decline, flooding, or water stress. And the good news is that if you go on these lower paths, the impacts would be severely reduced, and I won't go into more detail on those. Now we come to thinking about the international process for discussing this. And since 1992, we've had this UN Framework Convention on Climate Change. And under this, there's been the meeting of the parties. Now, I know parties sounds good to you, but actually all that means is the countries of the world come together to discuss the Framework Convention and what they can agree on. And they agree to try and prevent dangerous climate change, whatever that means. So there's been various things here, and many of us remember the Copenhagen meeting where we hoped there would be agreement, but there wasn't. But then up to this meeting in Paris, then new directions were taken, and the Paris Agreement last autumn, the early part of the winter, was really celebrated by many of us as the way forward, much more than in the past. So 196 countries agreed in Paris. That's amazing. North Korea was there. Saudi Arabia was there, you name it. They were all there. And they all agreed that climate change was a very serious problem they should do something about. And this is, you can't think of any other area, I don't think, where all these countries have agreed such a thing. And they agreed the temperature rise should be definitely held by that 2 degrees, and if possible, lower than that. Now, one of the secrets of the agreement this time was that all the countries of the world were asked, well, what will you volunteer to do in terms of reducing the greenhouse gas emissions in your country? So they weren't told, you have to do this. They were asked, what would you volunteer to do? And these were called the intended naturally determined contributions. And so that's what they would do now. And then they also put in place a mechanism that every 5 years they would look at what they promised and see whether more is needed and could they do more. And also there was a pledge of funding for developing countries. So those were the great things that were put in the Paris Agreement and that really set the signpost that we could be heading in this direction. So on 22nd of April, 175 countries actually signed this agreement in New York. That's a record again for signing any such agreement. But to actually be activated, it needs at least 55% of the emissions to be covered by those countries. But there are very good signs that China, US, EU, and others are taking this seriously and hope to ratify. So let's look at some of the implications of this now. So this is one picture of the emissions then that we've had and the direction we were going. This is where we should be heading for a 2 degrees or a 1.5 degrees world. This is where Paris, the pledges the countries have made, takes us. Probably keeping the temperature down to maybe 3 degrees or so. But there's a gap between there, and that's what this 5-year looking again, we hope the agreements can bring us down to that. So we're headed on the way, but we're not there yet. Now, I wanted to look at this in another way. And so here we have the carbon dioxide bucket here. And if you look at this curve here, then carbon dioxide put in the atmosphere stays there. And it's the area under this curve that matters. That's what determines the climate in future, because all the carbon dioxide will stay there. It doesn't matter if we put it in this time or this time. So that's all we're allowed, is the amount under there. And if we start later, we have to reduce quicker. So the amount on the curve is like a bucket then. So this is the amount that's been emitted up to between 2000 and 2014. And the size of the bucket is all we're allowed if we're going to stay, the Earth's going to stay below 2 degrees warming. That's what we added last year, 2015, and that's the 2016 drop coming in almost inevitably. And at the present rate, we'll have filled this bucket in 20 to 25 years. So it means you can't just wait to start. You have to start now. But equally, no one thinks really that we're going to manage to reduce quite at the rate required. And it may be that later in the century we'll actually require negative carbon emissions. So that means those two blue things down the bottom of my previous slide, either taking it directly out of the atmosphere or using biomass and burning that for energy and then absorbing the carbon dioxide. So that's our carbon bucket that we're filling up, and we can go no further if we're going to stay below 2 degrees. Briefly, I'll just say one thing about what's happening in the UK, that I'm involved with the Climate Change Committee there. We have in law in the UK the Climate Change Act of 2008, and one of the things this pledges us to is an 80% reduction in our greenhouse gas emissions by 2050. And if you look at what that means, so this was 2006 actually, and this is where we got to be in 2050. But I've shown this is electricity generation, the amount of greenhouse gases from that. This is from transport, this is from heating of houses or commercial buildings, industry, etc. up here. So how do we tackle all these? The number one thing is to be very efficient with everything we do. But after that, it's to decarbonize the electricity supply. If we can stop emitting carbon dioxide from the electricity supply, we can then use that in transport and in heating and in much of industry as well. So that's the key thing that must be happening now, is to go to different sorts of energy supply. So this is one scenario for the world then of what happens. This is where we're headed presently, and this is what the electricity, emissions from producing electricity. This is by efficiency, this is by renewables, this is by biofuels, this is by nuclear, and this is by capturing the carbon and putting it underground. So that's one scenario for the world about how we can decarbonize the electricity supply. We need everything. It's not just one. There's no silver bullet here. We need everything. I want to talk about the challenge to technologies just for a moment, and I've started with this thing here for the railway as an example. This was in 1829, this was Stephenson's rocket that won a competition for getting a moving railway engine, a locomotive, to pull people along. And that won around here, and this is how the passenger numbers took off after that. And this was inspired artists as well who had pictures of these railways. These things can happen very quickly, and the technology challenge, it really creates a huge industry with it. The mobile phone is a clear example of that. Not many years ago when they started, they were huge and they were totally unusable. Whereas once they were being used and being sold, the development of batteries and the development of the whole technology was very rapid. And now around the world, you go to a developing country, they have leapfrogged what we did. They didn't bother ever with this landline. They've gone straight to the mobile technology. I've put on a few electric cars here. You can have, there's your Tesla, the next Tesla. There's a BMW and there's the Nissan Leaf there. But again, this is just at this point of takeoff, because the electric car is becoming something that's really competitive and the advantages are becoming clear. Solar photovoltaics then, you can't read this, but this is the cost of solar photovoltaic per megawatt hour, which has dropped dramatically to be comparable with other forms of electricity production in terms of cost. And the opposite then, that the actual amount being produced in the world is doubling almost every 2 years. So the amount of renewable solar energy being produced. So if you're in a village in India, why bother to wait till the far power station and the national grid puts electricity down to you? Just have your local solar power, and that's much more exciting. So the challenge to technology generates new industries and lots of spillovers from those industries to other things. Challenge to technology, just the sort of challenge our economy needs, but challenges to businesses and foundations. Some of these will obviously come in as risks for a changing climate. And is their business really robust, resilient to that changing climate? Some companies, fossil fuel companies, are now seeing this as a threat because people are moving their investments away, and so that's clearly a threat. But many other businesses are seeing this as a major opportunity, and I think I've put some examples down here. Many top companies are seeing that they have to reduce their emissions, or seeing the opportunity So Unilever has put sustainability at the center of its operation for the last 6 years or more. Just recently, Bill Gates and similarly wealthy people announced a breakthrough energy coalition that they were going to invest early, broadly, boldly, wisely, and together. Well, great if they, with all the money they've got and all their business know-how. But again, this is the developing businesses and the developing industries. Now, the political challenge, which I've been aware of as I've got into this area. I mean, I gave my first public talk on climate change in 1985. So it was to the Clean Air Society in Scarborough, a seaside resort in England. And I gave the title, Climate Change, Will We Freeze or Fry? Because at that time there was some concern about the next ice age, and there'd been a program on the BBC which showed icebergs coming up the Thames. And I said that was the frying we had to worry about. So I've been in this area for some time. Now, I wanted to give 2 examples from Margaret Thatcher. She was the for the younger ones, she was the Prime Minister of my country for some years and made quite an impact on many of us, either for better or worse. And so she was the first world leader to take this seriously. So in a speech to the Royal Society, she said, stable prosperity can be achieved throughout the world, provided the environment is nurtured and safeguarded. And protecting this balance of nature is therefore one of the great challenges of the late 20th century. Now, that was when she was in her prime. Now, later on, when she was significantly not in her prime and influenced others, she wrote this, that the doomster's favorite subject today is climate change. This has a number of detractions. The science is extremely obscure. I'm sure I've shown you that. We all have ideas about the weather. Since clearly no plan to alter climate could be considered on anything but a global scale, it provides a marvelous excuse for worldwide supranational socialism. And so that was anathema to her. So the same lady did both of those. I like to think that she was thinking rather better in that time than that time. But this is the challenge to many of us, that we can be labelled as wanting world government. And so that is a challenge we get. And there is a certain member of the House of Lords in the UK who has challenged me on various times. And the recent arguments tend to be like this. What you're proposing for the UK will ruin our economy. Okay, well, that's an argument. And I would sort of counter that without these measures, the economy is really at risk. And with them, we have a new challenge, which actually provides opportunities for growth and sustainable growth that the old industries maybe won't give. Now, the second argument, I mentioned that Saudi Arabia even came up the other day with its Vision 2030, and Saudi Arabia said it's going to end its addiction to oil. So watch this space. Okay, so the other argument is, how dare you inhibit the growth of poorer countries by stopping them using fossil fuels as we've done? Why can't we just let them develop how we've done? If they have some coal, let them use it. And this argument from a politician who never cared anything about developing countries in the past is one that's difficult to take, but however, you have to answer it. And as I've already mentioned, these developing countries in the tropical regions mostly will tend to be hit hardest by climate change. They have the least resilience and the biggest impact there. And the new technologies like that can enable development that really is sustainable. You know, as I said, in a village in India, the solar power is the obvious thing to have. And the new technologies, why should they go through the same path that we've been through? They can leapfrog, as they've done with the mobile phone. Finally, then, this is a challenge to all of us, really, to society as well as to politicians. Can we look beyond our own group to a wider world? People are used to thinking about themselves, about their family, maybe about their village, perhaps their country. Can they actually think of the wider scene? Can they look beyond this week to this whole century and maybe future generations? Many of us find that difficult, and politicians certainly find it difficult to look beyond the next opinion poll, and certainly the next election is the end of the world as far as they're concerned. But we have to look beyond there. And around the world, then, there are many attitudes and implicit beliefs that will influence the reaction to a changing climate, maybe to say it's not changing, perhaps with some religious background to that, or saying this planet was given to us to exploit. There's all sorts of ways people will look at things, and we're doing that in a context of very different attitudes and beliefs. If we're going to do anything like this, then we all have to share some aspiration of where we wish to be, and that's the only way that we can take up this challenge. So my concluding comments then, by adding greenhouse gases to the atmosphere, we're taking a real gamble on the future of life on this planet. And it's a challenge to the scientists who have to see what we can say about that risk and what it means locally and what it might mean in the future. It's a challenge to technology to really develop those new technologies that are required and which will be the origin of the new industries and the new economies. It's a challenge to our economic ways of thinking and our political ways of working. Paris did give a great start. It's pointing in the right direction. But now, to go forward, we will require imagination, optimism, and leadership. The challenge of climate change, then we can tackle it, and we must. Thank you.
Thank you very much for an excellent talk. The floor is open for discussion and questions.
I can run around with Mike if
Okay.
he wants.
You mentioned that in the UK you had a limitation on greenhouse gases emission, whereas in Paris there was a limitation on temperature. Can you explain the consideration between the two limitations? It seems that temperature has a margin within it. Thank you.
So I was on the committee at the time that helped determine that number, and you can do it almost on the back of the envelope to see if we're going to end up somewhere near a 2-degree temperature rise. It is almost inevitable that by 2050 the global emissions will have to have halved from 1990 levels. So that's the global situation. How do you go to a single country? And what we used as an argument of equity, that by 2050 we thought that every citizen of the world should be allowed the same amount of carbon dioxide emission. We couldn't see any other agreement by 2050. And we were 5 times that level, so we should come down by a factor of 5. So from 100%, we should get an 80% reduction. So it's an equity argument along with somewhere where the world must be in 2050. By the way, the UK government accepted our figure, but they didn't accept how we reached it.
You mentioned that poor countries will be severely affected by climate change, and you said they should use other means of attaining economic development. Then how are they going to be able to attain economic development if you're refusing them to use things such as oil and unrenewable resources?
Yeah. That's a good question. I mean, I didn't emphasize it much, but an essential part of the Paris Agreement was the richer countries saying they will contribute a large amount of money to this fund to help the technologies be implanted in developing countries to help developing countries get those technologies, either developing them themselves or else being given from the developed countries. So it's not saying they have to leapfrog. Clearly, developing countries, the emissions from developing countries can be expected to increase for some time. And so the global emissions will be influenced by the developing countries reducing from now, or from earlier on, in fact, and then the developing countries increasing for a while, but then hopefully the newer technologies will gradually get in there and allow the reduction afterwards. You're not satisfied with that answer?
So most poor countries are found within the tropical regions, and
Yes.
those are the ones that are going to be affected most.
Yes.
And do you want to make me believe that rich countries are going to support poor countries in terms of financial means to encode this climate change? And if they did, do you think they have enough money to support their own countries and also support other countries? Don't you think that's vague?
I think the number was 100 billion that they have promised to this fund. So that there has been a pledge of funding to this. This is part of this wider vision. If you appreciate that we live in one planet, you can't just say, well, okay, we'll reduce our emissions and other countries can do what they like. We have to try and have a shared world where we will. And if as is the case, funding is required to be transferred to do it, then the developed countries have to do that. So that's part of my optimism that they will.
Can you raise your hand? Oh, there.
Yeah, I'm sort of turning back to the first question here, the relation between temperature rise and
Yes.
carbon dioxide emissions here. I mean, the link is climate sensitivity there. So
Yep.
in this bucket that you showed, there is some assumption of climate sensitivity. So what number did you assume, and how could you say something about how
Yeah.
it is affected by the actually rather large range in uncertainty in this parameter?
As far as the world political scene is concerned, I don't want to dwell too much on climate sensitivity because it is crucial that the global emissions peak and start to come down. Once they've started coming down, if we need to refine in terms of exactly where we go, then that can be done. But until the whole curve is coming down like that and the technologies have developed, if we wait until we know, this is the exact number, it will be too late. Yes. So we tried a range of numbers, and we tried models that were calibrated on the Met Office climate models, and we tried a range of numbers, and all of those were something like came down to something like 50% global emissions by 2050. So the climate sensitivity of those, I can't actually remember exactly what the range of numbers was in there, but it covered the range that the IPCC range, basically. And they're all, you can say the UK might have to reduce 75% or 85%, and that would make quite a difference in the number down there. But to the UK, it doesn't really matter now whether that number is 75 or 85. We have to go in that direction. So in terms of a developed country now and turning that emission curve over, it doesn't really matter exactly what that 2050 target is, which is why I'm not too concerned with where we were in the range.
Any further questions?
Hello, my name is John.
Hi.
I come from the International School of Stockholm region. I would like to ask you, knowing that the Paris Agreement was voluntary and that the INDCs that were put together add up to more than 2 degrees, what importance or how important does it make the INDCs and that the countries reach them? And what would you encourage citizens of different countries to do to put pressure on their governments?
Okay. There's a very big question there. So first, these are, the whole success of the road to Paris was really this move from top-down imposition to this bottom-up volunteering. It isn't enough, but two things may happen. One is the developing technologies may make this much more attractive, this reduction in emission, than it appears at present. And I'm optimistic that that's the case. Equally, there is this ratcheting process which will see just how is the climate system developing, how are the emissions looking. There is no international policeman to say you are not doing what you said you would do, but there is pressure, peer pressure, from similar countries, from other countries. But in the end, it will require the citizens of the world to actually say, we think this is important. And I think that's the only way it will actually happen, whether they're democracies or not. In the end, without the people saying this is important to us, that the world is habitable now and when our grandchildren are alive, then I don't think it will happen. But I think if there is enough information around about the climate system, what we're doing to it, and how it may change, and the opportunities provided by different ways of doing things, then I just am hopeful that people will put that pressure on.
On that note, I think we should thank you very much. And to do this, I will turn the floor over to Cynthia DeWitt, our board chair for the Bolin Center.
Yes. So, yes, on behalf of the Dean of the Faculty of Science, who could not be here today, I would like to present you with a diploma as this year's Bert
Thank you very
Bolin
much.
Lecture on Climate Research,
Thank
and
you.
some flowers.
Thank you very much indeed.
Here.
Thank you.